Okay, so we'll take a look here now at example 5 and try to use these definitions that we just constructed to help us understand how we could determine whether these series converge or diverge. Or sorry, not if they converge or diverge, but which of these colored titles actually applies to them. So if we take a look here at part A, notice again we have our good old alternating series or alternating harmonic series. So here's what we might be able to try to start with. Since the blue title is listed first, I'm just going to check that. Let's check to see if the blue title applies. Okay, so we'll start by saying we see that if we were to slap absolute value bars on our series, I could think about how this would change all the numbers that occur in the addition problem. Remember, this is the harmonic, but alternating. So when I take all the pieces in the alternating harmonic that are negative and I turn them positive, that should just turn into the formula 1 over n sitting in there, right? Because it's just all those same numbers now just being added. And we know this diverges. So automatically I could see, does this part A, does this series here, this alternating harmonic, can it be awarded the blue title? And we could immediately say no. So we can say that our original series is absolutely divergent. It's definitely got the red title. Okay. Notice though, I still haven't answered the question because the question wasn't, does it have the red title? It was, does it have blue, green, or black? And so far I haven't determined any of those. So maybe I could go ahead and take a look at some other things about the series. If I move to the green title next, I might recall that if you want to have the green title, you need to have the red, which is good because we already have that, but it needs to converge all by itself with no modifications. But maybe I'll be able to write this. We also know, and I'll put here, and we showed in example number 1, that this series converges by alternating series test, AST. So it converges totally on its own and has the red title. Well, that means it can have the green title. So I will say that this series is conditionally convergent. It gets the green title. Okay, so that's a pretty nice way of going through and working through these definitions. I typically always like to start by trying to identify the blue, and then working my way down to the green, and then finally working my way down to the black if I need to. Now let's try this again here, taking a look at part B. Notice this is not the alternating harmonic, but it's kind of like an alternating P series. But I'll start in the exact same way that we did last time. I'll say that we see that when I check to see if the blue title applies, whoa, that means I need to go through here and I need to slap absolute value bars on my series. Of course, when I do that, that's going to just turn this into a series that's a 1 over an n squared. But of course, this is a P series with P is equal to 2. And so it converges. Therefore, what title can I give the original series? Yeah, I can give this the title. This is absolutely convergent. It gets the blue title. Now notice that by itself, I have no idea what happens to this series. If I asked, is the original series convergent or divergent? I don't know yet. At least I don't have any work yet to convince me of any or either of those two answers. So I would still be a little bit stuck. Okay, so this is how I could start to use particular titles and start to apply them to different questions. In the worksheet for section 5.5, you will be able to see that there are lots of problems that will ask you to do the same thing. And again, I would very much encourage you to try to be practicing these worksheet problems as much as you can, because that'll be your best indication of if you're ready to do this when it comes to an exam. Okay, so in the next video, we'll take a look at one other important theorem that ultimately becomes related to these definitions, and something that we talked about before.